will receive an email, and you can use the certificate to share to the world, or you can sell if you need. Our next event will be the event, the Schrödinger Session in Verona with Luca Del Pupo on this 26th of October. And also we have a workshop with Rust, in Rust, with Luca Palmieri at Nana Bianca in Florence in the 22nd of November. And this is new. You will be the first to know that Open Source Day 2024 will be hosted in Florence on the 7th and 8th of March. You can find us everywhere. This is our QR code for Linktree. And thank you so much for joining in this event. And let me introduce the speaker, Erick Wendel, my kinda colleague in the GitHub Star group. And you can come into the come here and switch the PC.
Oi, oi. Olá, buonasera! Woohoo! Well, today I brought some topics that usually are very, like people say, it's very boring. So I've spent a long time building this talk to show you a step-by-step on how to use design patterns and how to refactor an application from scratch. So this was crazy, crazy nice. Well, I came all the way from Brazil for the conference tomorrow. Is everyone coming? Ooh, nice. So tomorrow I'm gonna speak there too, but let's get going. So before we start, this whole talk is not just for you to listen to. I want you to go at your home and try out the examples, try understand the whole thing, because I know it's a lot of content and sometimes you just get scared, right? So you're gonna have everything. If you can, please take as many pictures as you can. Mention the event. I know this is really hard to make, so support the community, support myself. This helps a lot. Well, on my YouTube channel, I've been making a lot of specific questions. Like my talk tomorrow is about recreating Node.js from scratch. I did a video recreating ESLint, trying to create minifying code, source maps, and it was crazy nice. So one of the things was why people think design patterns or this kind of strategies are so boring or so hard. Well, this was me in 2015, and I was giving a talk. It's like actually was a workshop during the whole night. It usually started like 11 p.m. and ended 4 a.m. This is how I learned programming. So they had a goal for you. You learn and you learn for free, and the next week you have to come back and teach what you learned. So I grew a lot with this. So it was ASP.NET with C#, and then I came with I started working with JavaScript, and I noticed JavaScript is not C#. C# is completely different. C# has a different paradigm, and I started struggling a bit with this. And I noticed JavaScript is very similar to TypeScript, but it's not exactly the same. You cannot apply everything that you have in TypeScript in JavaScript. Well, you can, but you're going to have to make some workarounds, right? So my first notice was, oh my God, is this just a mess? I was going projects, back then was jQuery, and people mixing up prototypes in the single file application was crazy. I was seeing single file apps, so most of jQuery, Angular, Angular too, yeah, back then, and no tests ever, so people were just creating and not fixing anything. and I noticed no folder structure. In C#, I've seen so many patterns that we had anti-patterns, right? So people say, no, you shouldn't use this. In JavaScript, I felt we were missing a lot in our community. Well, I noticed we can do it. And sometimes we've been using a lot of design patterns, and we don't actually know the name, right? We are just repeating and repeating. So, to get started, I'm gonna cover some very cool concepts. So the first of all is to reuse, and even for smaller applications, these structures are gonna help you to organize your code, to organize your projects. You're gonna learn some design patterns for testing. This for me was really mind-blowing. I didn't know that this exists, and this is pretty useful for like increasing databases. I'm gonna teach you how you can consume terabytes of data in JavaScript if you want, in the browser if you want, so you can consume data on demand, and you can inject behavior. So this is something that we've been doing a lot, but we probably don't know the name. Well, I told you I spent a lot of time on this because I built the whole application. So this application is very simple. You know how my design techniques are, right? So it's just a table. When you put some name, you can filter the table here. Pretty straightforward. All this application is just a single file application, and we're gonna go step by step refactoring it and making better, okay? So as I told you, it's just a simple HTML, a simple or not so simple JavaScript code. So this is a single file application, right? So we're gonna have some global variables there. We're gonna have some functions to parse HTML. We're gonna have the render using the inner HTML, and pretty straightforward, right? We're gonna have all the elements and fetching the database and do everything. Okay, for some studies this might work, but we know that MVP projects starts good, but it ends sometimes really bad, right? So in my opinion, the biggest problem we have there is that we have a single file application, so we don't have a single reason to change, right? We don't have a single reason to change it. So it's hard, and we have global state. Oh my God, this reminds me jQuery and doing like, you cannot use this variable because this variable is defining another library. So this was pretty hard. So the first tip, or the first, I would say, design pattern, but not so design pattern, is the N layers. Has anyone ever seen this one? Nice, nice, nice. So N layers is just like splitting your application in different responsibilities. So we're gonna have the service, which is every or any integration you're gonna have to external calls. You are on the web, you can use this for accessing websites. You're on Node.js to access your database. You're gonna have the view, which is your rendering part, right? The only one that knows the either DOM API or the Node.js CLI API for the UI, okay? And then the controller is the one just making the bridge, right? Calling one and another, but this doesn't know the actually implementation. So this is gonna be nice. So refactoring it. Now I'm gonna have the view, and I'm gonna have some standards here, right? All the functions and all the elements are just defined there. And notice I'm using ES modules, so I don't need to wait for the window.load. This is pretty straightforward. The service, all business rules is here now. So if I want to catch any external database, I'm gonna go there. If I wanna do some business rules, right, some computation, I would do from the service, okay? So we just split it in different files, and now we're gonna start making it more testable, right? More easier to maintain using dependency injection. This is pretty pretty common to see in applications, but I often see people not knowing why. So here we're gonna use the controller, which is making the whole bridge between these layers. So I'm gonna receive those layers, and I can call those functions, right? I can call those interfaces, but I don't actually know what is behind them. So this is pretty easier to make, and we're gonna have a init. Well, a spoiler alert, this is key for us to creating universal JavaScript apps without any framework or library. So this is gonna be easy. And then we're gonna have the factory. So factory is amazing for putting all your dependencies on one side. So usually dependency injection and factories are going together. So you're gonna have a single file for importing all the modules, creating your instance, and you can handle for there. Imagine now you are working with a HTML page, which the view could be handling the DOM. But now you're gonna move this application and work on CLI. You can just change the module and everything's still working, right? You don't have to change 3 different files. Okay, software is crazy, right? Sometimes we get crazy ideas. Sometimes our boss just like, oh, this is going pretty well. What if we try doing something, right? What if we try grabbing your index.html page, your web page that's working fine, and we're gonna port it to a CLI program? Well, some people might freak out now, but one thing that we forget about JavaScript is it's a single language to rule them all, right? So we can use JavaScript in the browser, in the Node.js, IoT devices everywhere, even like smartwatches. And we can just reuse this code everywhere. So this is pretty nice. So I'm gonna show you the abstract factoring, which is one of the best patterns for me for creating UIs, even though I'm a backend developer, right? So now you can see, I just splitted all the application in different responsibilities. Even if you don't know any design patterns here, the idea is just break into different files or folders. This is gonna make us, it easier to maintain. So in the console, I'm gonna have the Vue.js file. I'm gonna have the web, but what they are gonna have there is just the signature. I'm gonna show you in a bit. The cool thing here is we're gonna have a shared layer, and this shared layer I can use to control the whole flow. I can have the controller, which as the controller don't know the current or the whole implementation of the file, it's just calling the functions, and it's pretty nice. And then I will have the view, and for the view I can notice which platform I'm running on. So here I notice, well, if the window is not present, probably I'm gonna run this on Node.js, and then I start rendering the CLI. Or else I can run on the web and just use DOM APIs and try dynamically importing those modules using exactly the same code. Imagine, hello! Imagine I will have other layers. Imagine I wanna run this on my clock. I can just put different layers here and it's gonna work pretty well. All right, as I told you, I'm gonna have the console. So Vue, all those layers are gonna follow the same interface. So they are following the same function names. Why? Because the controller doesn't know what platform it's running, right? They only know the data flow. So on console, the data flow is just render. On the web, just render, and so on. And this is the power of abstraction, right? We can just reuse code. For me, I don't know about you, but when I can, we have this joke, right? When we can automate something that would spend 10 minutes in 2 hours, we can do it. So here, the shared layer, the whole abstraction. As I told you, I don't know what is running behind the scenes, but I know the data flow. All those platforms, all where my application is gonna run, it's gonna call those functions and it's gonna render depending on the platform it's running on. So this is pretty cool. See, the same application, the same code, but the view, the only thing is different is the view. It's the rendering layer, right? Now, I'm gonna have the beautiful table I had there. And then, on the Node.js side, I'm gonna have the CLI. This breaks some myths, right? Because people say, no, I'm a backend developer because I work on Node.js. I'm a front-end developer because I work on the web. Well, if you do UI on a CLI, it's front-end, right? If you do, if you're working on APIs and just reproducing your APIs like a Postman or Swagger, this page is a front-end, so people just mix sometimes. Builder is amazing for building AIs also. So here I was using Blast. Blast is a very nice framework or library for creating that beautiful view that we saw on CLI. So I'm gonna have a bunch of methods for building like fragments of my UI. So I have set table, all the CSS that I might have for the application, and then I'm gonna have the build. Okay, a bunch of methods, right? But then I can see this working fine. So when I see this code, I know what it's doing there. I know the whole step by step. So I have set screen with the title, the layout. So I build first the square and then the search component and so on and so forth. So this is pretty amazing when you have complex objects, right? You have to do a bunch of steps you can break into different function calls. And set screen. Forgot the animation, right? And build. Nice. So yeah, Fluent API. So I noticed Builder and Fluent API are very similar. The difference is the Fluent API you can call the same function different times. So this example is a YouTube video I made making like a Fluent SQL builder. So we're gonna call each different functions, but this is not perform anything on the database. It's gonna go to the database only when I call build. This saves us a lot of processing time, right? Sometimes I see people like where, and you run filter, and then like limit, and then you have, this is crazy, right? The best way for us is to work with fields on demand. So this helps a lot. Well, this happens a lot, right? Either you fix your code to pass the unit test or just remove the unit test, right? It's crazy. This for me was the mind-blowing when I noticed this. So you have a design pattern for helping on testing. Has anyone seen this before? Oh, nice. I would say your mind is gonna blow now. Well, what is the point here? I'm gonna have a class or a function or a object, and the default value is valid. So here I'm just making an example with fetch. So the default thing is it's gonna return a single JSON line, and the status is 200 and status text is okay. Then I can have different functions for that. So imagine 500. I can build a different object. 404, different object. Invalid body, exactly the same thing. So I can fluently build my object instead of just copy and pasting, right, for using cases. So this is, it's pretty straightforward. When we see this in practice, see how beautiful it is. A response with status 404 and dot build, exactly what I wanted. So you can have like someone working with people from product or business building all those different status for your object, and then you can just call and reuse this, right? And the cool thing about JavaScript, you can use this in both backend and frontend, which is completely controversial now, right? What is backend and frontend? All right, so you can call your data there, and we have observer. This is something that is the foundation of JavaScript, and people sometimes forget it. In Node.js, we have event emitter. In the browser, we have event target, right? Everything is based on events, and all of them came from the observer. So in the observer, you just, it's the theory like, instead of calling, instead of polling, right? Asking you for the information all the time, I say, okay, I'm gonna hold you now. When I'm ready, I'm gonna call you back, okay? So the whole point here is I'm gonna subscribe, I'm gonna put a bunch of listeners here, and then when I'm ready to send an event, I'm just notify everyone. This is exactly the same. The on object we have for subscribing to events, and for notifying we use emit. So this is how Node.js and a bunch of other patterns are doing behind the scenes. But like I was doing some application on the front ends on the website, and I noticed the event target is doing a bunch of stuff. I wanted just to have something like the event emitter. So I would use this class to make something simpler, and it's not gonna cost the whole life cycle of a page. So it's nice. And then just one thing that I miss here, it's from TypeScript or for other languages, is to have at least interface, right? Because now I have to make sure all observers have that function notify. So I'm gonna have to make some, I would say, workarounds to make sure they are implementing this function. So this is probably something harder in JavaScript, but it's all set. All right. Well, thinking about the same thing, we can have different functions doing a bunch of stuff. What I'm gonna do here now, I'm gonna try monitoring the performance of this API, sending events for different observers. So I will have the log observer, and I would say I'm gonna have the analytics observer. So one is just gonna print out results, and the other it's gonna run all the time I have something new, I'm gonna send to a different API. So this is pretty straightforward, and see, they are just following the same interface. They are using exactly the same name, and this is key for us to start working. Nice. I told you, it's a lot of information, right? So now, when I'm using this, I'm gonna use subscribe, log, subscribe, analytics, right? When we are using Node.js, we're gonna have like analytics dot, I would say, yeah, it's gonna say like subject dot on and execute something. Exactly for everyone, right? But when I'm calling the notify, all the subscribers are gonna be called, right? So this is, it's pretty straightforward when we're working with a bunch of objects, and this is pretty common to see in JavaScript, but people don't often see where this came from, and it's very nice. All right, and decorator. Well, this one, I often ask my students about what is decorator, right? They call me and say, no, decorator is this that we might see in JavaScript, right? In TypeScript, and I hope in JavaScript soon, right? It's in the last stage in the TC39, but this is one of the hardest things, I would say, to implement in JavaScript. But internally, this is just a proxy, right? Just a wrapper that we're gonna put on the wall, and we're gonna try processing something and just keep the process going on. So see here, I know it's a bunch of code, but what I'm gonna do here, I'm gonna use measure time, and then I'm gonna pass through a function. It's exactly the same thing I would use with at. So I'm gonna have the function. I'm gonna notify all my observers that this function is about to start, and then I can call it and actually execute it. So I'm gonna mark the performance when this started. I'm gonna notify everyone, and then on this function, I'm gonna actually execute the current function, and then I'm gonna notify again all of them, okay? So I'm gonna have the duration and notify when this came from. So I think with this example makes more sense to analyze how to use them. And then I'm gonna use the performance decorator and see how we can use it. We can just have, it's not so beautiful, right, in JavaScript yet, but it's exactly the same thing that we put at measure time, and we would do exactly the same thing. See, sometimes this design patterns, I would say it's from 80s, right? It's a long time ago that it's able to use, but as the language doesn't provide this by default, we sometimes like, oh, I'm not sure if I should use this or not. But I would say probably most of APMs, right, the application performance monitoring tools, they are using this kind of approach to handle it. So let's see if this works in practice. This is the application I told you that I made. So there, in the web, I can have the tag web. On my server, I'm gonna see the web is coming there. So it's exactly the same application, and I'm gonna receive exactly the same behavior. See, this is a very complex behavior, right? I'm monitoring, I'm logging everything using different JavaScript code bases, but they are working on Node.js and in the browser with no frameworks, no Webpack, only JavaScript. So for me, it was really mind-blowing. All right, I told you I'm gonna teach you the secret for consuming terabytes of data with JavaScript, right? Well, we have the async iterator protocol. So what is the point of JavaScript? People come from C# and other programming languages, and they're like, oh, but JavaScript is not so good because I cannot put all these objects in memory and just try processing. No, the key in Node.js is to process data on demand. As soon as you have the data, you just pass through and keep going. So let's see, how's the problem in practice? Well, my beautiful application, right? Bootstrap, yeah, nice. So the problem here is, when I'm starting the application, I can see this whole white thing, right? So it's something is causing some bottlenecks here, and it's not so perfect for my experience. So if I take a look at the current API, I'm gonna see that the API is writing data and waiting for some time. So instead of holding the whole data in memory and then calling on end, it's calling all the time it's available. So what if we could grab this data on the front-end side, on the website, without having to wait for the whole thing to finish? And using ATP, right? Something that I didn't notice. I'm using here response.write. So if I call this 100 times, it's gonna call our response on the website there 100 times too. So we can start consuming this right away because it's a socket, right? But then just to finish the whole request, you just call end. So now we're gonna change a bit our code. Now I'm gonna use web streams to consume this data. So what I tell here, I tell, well, once you are ready, once you start receiving data from the front-end side, you can start reading this in chunks, in small fragments, right? So in the red chunks here, I'm just making sure I have a full JSON item. And then once I have the full JSON item, I'm just parsing and I'm using yield just to call back and just start rendering or parsing data on demand. So this is pretty nice. So this is, in my opinion, the most powerful tool we have in JavaScript because we can process data on demand. Well, in other talk I gave about Node.js streams, I was consuming the random, the dash random on Linux, which is an infinite file, right? So people say, oh, how is the limit of memory I can consume? I was like, it's infinite because, I mean, it's a bit cheering, right? Because we can consume this data as like, let's say 1 megabyte, 2 megabytes. So it doesn't matter the size. Once we have ready, we just sending right away. So it's nice. So let's see how different is the code now. If we run the application now, see, it's smooth now. Even though I have a performance issue on the backend side, once I have the application running, once I have the first item, I start rendering. I don't need to wait. For users, it's way better. And for the backend side, exactly the same behavior. So it's exactly the same code using on both back and front end. Just notice one thing. I'm using web streams here, right? So web streams are ready to use in both Node.js and web browsers. But Node.js streams is a completely different specification. So you cannot use in the browser yet. All right. Did you like it? Woohoo! Nice. So now, as I told you, right? Nothing is for free. Now you have a task. So you go there later. I'm going to show you the barcode. So all the step-by-step I use on my slides, I put on those folders. So you can go there and start noticing. And you can start applying on your job or trying fixing things that you are just copying and pasting because this might help a lot. Later, I want to know what was the mind-blowing design pattern that you'll find out, okay? Well, my talk tomorrow is about recreating Node.js from scratch. So it was the crazy experience I have done on my whole life. So I built a ebook. So if you want to go there, there are also challenges for you to implement your own rig file on Node.js using libuv, C++, and everything. Man, this was crazy. But yeah, go to my talk tomorrow. You're going to see more stuff about this. Okay? Well, all the content I've been doing is already on my website. I would say most of them because it's missing to update, right? I should follow my own words, right? Once it's available, I should put there, right? Not wait in memory. Yeah. I should follow my words. All right, so that's it for today. If you want to take a picture for this, because this took me a long time, I want you to follow along. Show to your bosses too. And before we finish, I have like a tradition to make people envy at home, right? So I'm going to record a video. I'm going to do, woo! Okay? Nice. So on 3, oops. Let me try. So I'm going to count on 3, and we just hands on the air, okay? So 1, 2, 3. Aye! Thank you. Thank you so much for having me. 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 Thank you so much for having me.
If everyone have some question, no question?
Well, let me ask a question. What, like, the guy in the back, what was your best design pattern for you? The last one, async editors, consuming terabytes of data in JavaScript is mind-blowing, right? Java developers got crazy. It's nice. All right?
Okay, thank you. Thank you, Eric. The session is not finished. We have a surprise. Mishko have a surprise. And we need to switch the PC once again. Yes. What? You need to. I know, but like, how to? It was a question. Wait, how do you put this on? Here we go.
So, hello? Oh my gosh, it is backwards. All right. So, I came here to do magic tricks. And every time I do a magic trick, I want you to go, oh, and ah. Okay? Okay. Oh, look at that. Oh, wait, you're seeing my personal stuff. All right, hold on. Let's close that. Let's close that. VS Code. So, while I'm getting this thing up and running, I like to tell dad jokes. Did you know that about me? Yes. You did. Oh wait, that's not the wrong thing. So how do functions break up? They stop calling each other. Here we go. All right. Okay, font. Something like that. That's a good size font, yeah? What? Oh. And clearly I'm not prepared because I really wasn't planning on doing this. But let's see. Localhost. No. 5173 shop. Yes. All right. Ah, good. But that's nothing magical yet. Okay, so for my first magic trick is I want to show you this app. It's a kind of a demo app, nothing really that exciting. You know, there is like some menus here. There's a shopping cart, a number of items. It shows one item. If you do hello from quick, it prints the console log. You can increment and decrement things here. There is a shopping cart. If I hit buy, then you can see now I have 2 items in the shopping cart, and it says it has a travel mag now in there. And there's a clock that runs over here and updates itself. Okay, so that's the background. Let me show you the magic trick. So network tab. Let's go show JavaScript. Now, this is running in Vite in dev mode, and Vite sends bunch of things. So I'm going to say, show me everything but Vite. And my first magic trick is that there is no JavaScript. Okay. So actually, before I go, I should kind of introduce myself. So first of all, hi, I'm Mishko. You probably know me as the guy who did Angular and AngularJS. I don't know how many people have used that. Nice. All right. Do what? Too bad. Too bad. Okay. And I'm working on this new thing called Quick. And Quick is a new kind of framework that is very different from everything else you've used. If you used all the other frameworks, they kind of work the same. The syntax is different, but they work the same underneath underneath it all. Quick works very, very different underneath it all. But it looks very familiar, like it's intentionally done this way. So if you're actually a React developer and you look at Quick, you're like, oh, it's very familiar, like it's everything the same. But the way it works is very, very different. And the first magic trick that the Quick knows how to do is to basically show you, hey, there is no JavaScript and yet things happen. So let's try to say hello from Quick. When I click on this, notice code shows up. But the only code that showed up is literally just console.log, nothing else. Wait, how do I get the console to be up here? Okay, perfect. If I click on here, notice that the only thing that showed up is console.log because the system looked at it and said, well, you're asking me to say console log, and so that's all I'm going to do. So let me show you the source code to this. So shop, okay, so here's our shop, and you can see there's a whole bunch of components over here. And let's open up the greet component. And the greet component, notice it just says console log, whatever you see over here. And so that's the only code that shows up. As a matter of fact, if I do console dot log render greet, this particular greet, if I go to terminal, will show up. Let's see, I think look at it. Okay, here we go. So it renders on a server, so then the render greet shows up on a server. But if you go and click on a client, it says hello, but the actual component never showed up. So Quick knows how to look at your code and say, you know what, all this other stuff you wrote, I've executed on a server, it doesn't need to run on the client, so I'm not going to send it to the client. And as a matter of fact, in this particular case, the only thing that Quick sends is this function. But wait a minute, this function is actually embedded inside of other code, and so Quick knows how to extract the function, make it importable, and then do this particular magic trick. Okay, thank you. Okay, now, the thing is, this function is relatively easy to extract, right? Because if I did something like this, I'd say export const click equals, like that's easy to do. And the reason why it's easy is because this function has no closure. Normally when we have functions, they close over variables, right? So let's look at a more realistic example, which is the counter. And in the case of a counter, we have a button that goes and increments the count. And notice if I try to extract this function like this, export const click equals, it's not going to like it, right? Because it says, hey, this count stuff, what happened to it? So that doesn't work. But yet, our button works just fine. It goes and performs the operation. And notice that, let's do this again. Notice the plus downloads just a piece of code for incrementing the code. It then downloads the framework itself in this particular case. And then there's this build thing that disappears. And then the minus actually shows up as a separate thing. Now, I know what you're thinking at this point. You're saying, well, wait a minute. Doesn't that mean that every time I interact with a page, I have to wait for a network request, and therefore that might be slow, especially on a mobile network? Well, this is how this works in dev mode. In production, it actually works a little different. What happens in production, let's go to our site. Oh yeah, I have no internet. Guest. Let's see. What is it? It's come dream with us, exclamation. Okay, at first when I heard they told me the password, I thought it said come drink with us, and I'm like, what are you, a bunch of alcoholics? But I misheard it. This makes more sense now. Okay, so here is our website. And I wanted to show you that in the real website, there is a service worker, which is running right here. That's right here. And what this service worker does, it immediately goes and prefetches all of these files that are necessary for the running of the application. And these files get automatically prefetched so that when you go and interact with the page, it's a cache hit. So when I do an operation, let's go to network tab. If I, the network's empty. If I go and I click on something, all of these files, if you look at the times, they're showing super low times, like 3 milliseconds. And that's impossible to have any kind of network in 3 milliseconds. And the reason why it's showing 3 milliseconds is because the service worker already prefetched it and the service worker is responding. So even if I disabled the network, it would still work because the service worker went and prefetched. I mean, this is another interesting thing because that's not how you normally think about working with your application, because the way you normally think about it is that loading and execution is the same thing. In Quick, loading the code into the cache is independent from actually getting it from the cache into the V8. Those are two separate steps. So we talk separately about eagerly downloading the code, but lazily executing it. And that's a trick that most frameworks don't know how to do. But anyways, let's go back. Oh yeah, but before we do that, let's talk about these files over here. How did the system know how to do this? Well, what if the system can observe your interaction. Oh, come on, you're gonna make me log in now. Hold on, we can do this. Maybe I have a separate profile that I'm already logged in. Profile, quick insight, here we go. Here I'm already logged in. And we can go to Quick Builder, here we go. And so what this thing does is it observes how the users are actually using the application, and it keeps statistics and basically knows, for example, that if you go and interact with a particular symbol, so that hash, I know it's a little low, small to see, let me see if I can make it bigger. That shows that if that symbol is needed, then there is a 87% chance that this other symbol is needed. And so Quick uses this information then to create bundles. So for example, this is a relatively large bundle that has lots of code inside of it. Quick basically looked at it and said, you know, I always see that all this code is needed together, so I'm going to put it in the same bundle. And then not only do we download all this code, but we then can go and tell the service worker to download these bundles in a specific order. So a button, so if we go to our page, for example, again, a button that you know, is a search button that's used a lot is going to be prefetched first, and maybe a button like, you know, explore the docs, which is not used very often, is going to be you know, later in the. It's still going to be prefetched, but it's going to be later. And so that means that you can go and interact with your application much faster because we actually order the list of these bundles that we can do. Most frameworks, because of hydration, require fully downloading all the code on the current page and fully executing it before you can interact with anything. This thing can sort the order and automatically do this and do this. Now, the important point is every framework will say, we know how to lazy load. They're not necessarily wrong. The interesting bit is that in Quick, you get lazy loading without moving a finger. There's nothing you have to do. It's just how it works out of the box. Okay, so let's go back to the shopping cart and let's talk about this. So this particular button here, as you can see, knows how to, is the microphone on? It's kind of cutting in. It knows how to capture the state of the system and execute it. And then again, you're going to notice that the render part, this part here, executes on the server, and so you can see it executing on a server right here, but it never shows up on the client. The render client just never shows up on a client. Well, thank you. Now, the important thing to kind of realize is look at the shopping cart right here. So there's a buy button, and the shopping cart is pretty far. That means that if you look at our application, the application has a shopping cart state, which is a top-level component, and it takes that state and passes it down to cart, and then passes it down to the shop, which then has the buy button, right? And so you have this tree where when you have something that's far apart, like a button, the buy button and a cart, you have to put the common state super high up, which means that if I push the buy button, I have to go and mutate the state in the root component, which means that component has to be downloaded. And then, because it's a root component, it will cause a re-rendering of everything below it, right? And re-rendering means all the code has to be present, too. So let's see what is needed to hit the shopping cart button. So here, nothing's here, no code. I hit buy. The first piece of code I have to download is the listener that pushes the code into the shopping cart, right? So I get a hold of the state, and I push data into the shopping cart. The framework shows up, and the framework says, you know what? I also need to update the number. Wait, what? Use lexical scope count file. Why is the negative number? Wait, what? Sorry. By. Okay, and now the number is updated. Okay, so the piece of code that pushes the travel mark shows up. Then the framework shows up. That's the build. Then the JSX associated with the shopping cart only, because if I expanded, this JSX is right here. And why is the -1 button showing up? Did I click it? Whatever. This one shouldn't be here. I'm not sure why it's showing up. But the point is, the other components didn't show up, right? The root component that contains the state, or all of the components underneath it, which is basically this whole demo, none of that stuff showed up. And that's a trick that I don't believe any other framework can do, because when a data flows through the system, at the very beginning, all frameworks require that all the components are executed at least once, And then frameworks that use signals, such as Solid.js, can do this trick. But it's already too late. They already downloaded and executed everything. Whereas here, we never download and execute any of these things. Now, I have one more thing that I like to show, and I have this clock on the bottom. And what I want to show you about this clock is that the code doesn't show up until I scroll the clock into the position. The clock knows how to do this. So, and how does it know how to do this? Well, if you go to the clock, it simply says, I have a state, and I need to be updated myself. So use visible task is kind of like use effect, but it only runs on a client. And in this particular case, it basically tells you that I'm only going to run if I become visible. If I don't become visible, then there is no point in running. And this is just a natural way of writing code. It's just like you would use effect. You have to use visible task. It's very similar. And then you have, of course, the JSX associated with it, right? And in the case of a clock, the only thing that showed up was the effect associated with it, right? The framework, and for some reason, the button for subtracting the value. Why is this showing up? I have to look into this. But even with that extra file showing up, it's still like miles ahead of a typical framework that downloads everything. And so I think this is kind of cool that you can, without kind of any sort of effort, right? Without trying to lazy load anything, just in a normal way of writing components, you end up with this particular behavior. Now, I want to show you though one more thing, because Eric was talking about this idea of, am I a front-end or back-end developer? And I really want to squash the two ideas together in a way that you have never seen before. PHP developer. All right. So here is our console log that prints hello over here, right? And so if I go and I click this button, I will see that it says hello as I'm clicking the button, right? So far, nothing's exciting. Now, imagine that I have something that's expensive. So I'm going to say console log expensive. Okay, just bear with me. Imagine it's expensive. And so obviously, if I click, it's going to say hello and expensive. But what if this expensive thing only runs sometimes? Like, let's say math random 0.5. So now it only runs sometimes, right? And so now I have a problem that, like, I click this button and I've downloaded the code that I don't need, right? If I look at the code that's associated, it shows expensive because it's behind that. So let's say I wanted to lazy load this piece of code. So if I wanted to lazy load, all I have to do is turn this into a function, right? So that in itself doesn't do anything, right? And so now I have to invoke the function like this. And so if I want to lazy load it, all I have to do is wrap it in a $sign. Basically, everywhere you see a $sign, you are lazy loading code. And it's not like you can forget to put down $sign. The system complains, right? So it's not like you can say like this. It's not a valid piece of code. So just by wrapping something in a $sign, notice we're going to have this behavior that, hey, this hello now showed up without the expensive part. And if you look at the source code, you'll see that where the expensive part was, we have a dynamic import. And so if I click again, now the code showed up. Now the expensive part showed up as a separate piece of file. So lazy loading in Quick is very effortless. And oh, by the way, just because this now got lazy loaded, Quick Insight can now kick in and look at the statistics of what people actually use, and based on that decide whether or not it's worth to bundle it together or not, and in which order it should be downloaded, and all that stuff just happens automatically. That's everything hiding behind a $sign. So let's do another even cooler trick. How about it's expensive not in the terms of size, but maybe in terms of computation. And I want to move this work over to the server. So now when I click the button, the hello shows up on a client, but the expensive part shows up on a server. All just because you've put server $sign. You pinned the function to the server. And so now you should be thinking to yourself like, wait a minute, this is very muddy. Like, I'm sometimes on a server, sometimes on a client. Like, my application runs on a server, but then runs on a client, and it's just seamless without even thinking about it. And it's not just this. I can, for example, do weird things. Like, for example, I can say value equals 10 here, and I can say value. And this value is declared on a server, then goes to the client, and then when I click the button, it says expensive 10 because it came back from the client, right? So you can capture things inside of this particular bit. So let me actually move this function up a little bit, and let me show you another trick. Option, here we go. Magic. Okay, so we have our function here, and so far it just prints console log. But what if I will turn it into function? What if I turn this function into a generator, and then in here let's have a for loop. I is let's go from to 10, and let's yield I, and then delay 1000 milliseconds. Of course, we have to create a delay function. Delay time. Come on, autopilot, you're gonna help me? No? Okay, what is it? Return new promise. No, what are you doing? Promise. Resolve is, no, how does it, it's a closure that takes resolve that says set timeout, which runs resolve in time. Something like this. Okay, so now we have a generator that goes and updates the stuff, and let's say do const text equals use signal. Well, actually, it would be, sure. Let's start with an empty thing, and let's just print it here. Okay. Yeah, so now we have to do const. Wait, what is? Oh, the delay. Yes, sorry, thank you. Sorry, thank you. Yes. So now we get stream, and now we can do, what's the syntax? For await const data in stream. Is that the off? And then we do text dot value plus equals data. And why is this not happy? Must have, yes, async. What am I doing wrong here? Oh yeah, I have to await the magic. Thank you. I was just checking if you're paying attention. All right, let's see. So now, look at that. I am streaming data from the backend. Thank you. How am I doing on time? You can go out forever. I think I promised them half an hour, but I'm going to pause here because I think I showed off all the kind of main things, and I'm going to see if people have questions. First of all, how many people have heard about Quick before tonight? Oh, because Giorgio's awesome, right? Okay. But questions, what can I answer for you?
I have a question.
Yes.
You showed the server thing. Now it's a very silly question, probably.
Yeah.
You have the server there,
Yeah.
so this means that you can have all the routes, databases now on Quick.
Yeah.
So this was gonna replace other frameworks or something.
Yeah, so we have both Quick and Quick City. So Quick is like your replacement for like your normal framework like React, Angular, Vue, Svelte, whatever. And then Quick City is for the meta framework like Next, SvelteKit, Solid Start, etc. So we have both parts of it. Both of them are running, yes. There was a question behind, yes.
I would ask where are stored the statistics by the user usage? The real question is, can I share these statistics between pods?
These statistics are shared right now. We have, this is kind of what we call labs, which means we're just trying this out. It's kind of in an alpha state, the statistics. But as of right now, we're sharing it for, we have a database in the cloud that you can send data to. The data we send across is completely anonymous. The only thing we know is the SHA, which is this hash, right, you see over here. and time delay since previous SHA. So there's some like 3 different time delays that we keep track of, and we send this to the database, and the database doesn't store individual things, it only stores aggregate statistics. So there's no way to track individual user, we can only talk about overall the system. The code is open source, and so if you don't trust us with the data, not that you can do much with it, you can host your own.
No, the real question it was if I can share between instance of server.
Yeah, so this data is used for making a build. So this is not a runtime thing. It's when you're making a build, it's at that time that you make different kinds of builds. Because you want to solve answer 2 questions. The question 1 is, I don't want to have waterfalls, and therefore I want to put things that are needed together to be together in the same file, right? So that is answered basically what I showed you here with this correlation matrix. The second part you need to solve is, okay, now that I have these bundles, in which order should I download the bundles for a particular route, right? And so all of this information is collected here, and then that information is used to make the next build better.
Have a question?
Yes.
So what is the name of the technique behind loading just the piece of JavaScript that I need on the front end? And if it's common, why other frameworks are
not doing it? Okay.
not doing it? Yeah.
So the technique, we named this technique, it's called code extraction. I wrote an article on this, blog, builder, IO. There's an article, here we go, what the fuck is code extraction? Here we go. There's a nice article that I kind of explained. There are other frameworks that are doing it in a much simpler way, but I am not aware of anybody doing it to the level that we are doing it. So for example, Next.js does this trick where you create a get static props, and as long as nobody's referring to the get static props, nobody's actually calling it directly, it gets tree shaken away, right? So it never gets shipped to the client, but the server can call it because the server build is without the tree shaking, right? Enabled. And so that's a simplified version of code extraction. What we have here is basically code extractions on stereos, where we use a marker and then marker is the $sign. And so whenever the compiler sees a $sign, the compiler says, oh, you want me to extract this to a separate file. And so it does this automatically. So in a dev mode, it moves it to a separate file, but then in the production, we have the quick insight statistics, and we can put them together based on how the real world usage actually is. And keep in mind that the amount of JavaScript we download is significantly less than an equivalent other framework, because if you look at this page, the demo page I was giving you over here, most of this HTML never has to re-render. And because it never has to re-render, the code never has to be shipped to the client, right? So in a normal framework, all of this HTML that is needed to build up this particular page would have to be shipped to the client, right? Because there might be a listener somewhere and we need to know about it, and that's what hydration is. Here, we only download the component if it has to be re-rendered. And it only has to be rendered if there is a structural change. So for example, in the case of a shopping cart, when you hit the buy button, this is a structural change because we have an extra row. So this requires us to download the JSX associated with this component. Not the child components, just this component, or parent component, just this component itself, right? But in the case of the button like you see over here, the JSX is never actually downloaded because it's not a structural change. It's just an update to attributes. And because it's just an update to attributes, we don't need the JSX. We know exactly what's connected to what, and we can just do it directly. Other questions? Who's going to start using this? Who thinks this is like amazing and it will solve your problems? Yeah, 1 person, 2. All right, good, good, good. So if you have, okay, let me show you one more demo. Actually, come to think about it. Okay, one more demo. This is our landing page. This is Builder.io. This is the wonderful company I work for. And I wanted to show you, let's see. So let's go to performance and let's load this particular page with this is actually running an older version of Quick. So give it a second. Come on, do your magic. Now, because we are a visual CMS system and we have this amazing tool called mitosis, we can generate the same exact page, but we can render it using Next.js. So this is the same exact page. So one-for-one comparison, no difference. And now this is running Next.js. And so let's have a comparison between Next.js and Quick in terms of the amount of JavaScript we download and the amount of JavaScript that has to execute or anything else you want to look at. So let's see. Come on, do your profile. Come on, do your magic. Okay, so it took 420 milliseconds to get the page running. And if I zoom in here, let's see. So the page, oh, come on. How do you use this thing? Okay. Where am I even? Oh yeah, I see. Okay, I have to close this. So I'm looking at the first 2 seconds of the life of the page, right? So let's look at the first 2 seconds of the life of the page here. Okay, 71 milliseconds of JavaScript. Huge difference, okay? But you should really be looking at what's happening over here. First of all, the page showed up much earlier. But look at the, I guess the flame chart is what you want to see. How do I do flame chart? Cold tree, oh, here we go. So notice that the flame chart is pretty empty. Whereas if you look at the flame chart here, notice how thick it is, right? This flame chart, what you're looking at over here, that's hydration happening. And, you know, this is a modern CPU. Again, imagine mobile device. This would be multiple seconds, and it's not unheard of on a mobile device to take 30 seconds for the page to come up. So if you want a page that is instant on, nothing is faster than just pure HTML, right? And a demo I've showed you is pure HTML. Nothing is showing up here, just pure HTML, and yet the page is interactive. You can't beat this, right? The code shows up later, and the code that's showing up is specific to the operation you want, right? So if I'm a user and I want to click the buy button, why download the menus, all the other things, maybe some footnotes over here or clock or whatever? The only thing I really need is the code behind the buy button and the code to update the shopping cart. Nothing else. Nothing else should show up. Thank you, thank you, thank you. And so if I was to run this thing through, let's see, page speed. Is it page speed? Let's see. So that's the quick version going through page speed. And let's do another page speed. And this one is render equals next. So let's see the difference in page speed scores. Come on, it's going to be a second to come up. But there, usually we get around 90 in the Quicks site, and we get like 40s. Oh, look at only 86. 90 is a magical thing when you become green. Why is it 86? Okay, I'll have to investigate later. But let's see what Next.js comes on. It comes at 49, right? So it's a huge difference in performance. And you know, I love the comments that Next.js gives you. It's like, oh, you're executing too much code. It's like, yeah, I know, but what am I supposed to do about it? Look, main thread work took 8 seconds on the main thread, right? And so this is kind of the motivation and the thing how Quick is different. One of the things that is, because Quick pages are HTML first, you don't really have to think about SEO, right? Because, I mean, there's still stuff to think about it, but like the rendering is not something you have to think about because it just comes out of the box. Other questions?
Last
yes.
question.
You're still using JSX as the language, right?
Yes.
It's still JSX.
Yes.
So it still allocates a huge amount of elements and stuff on the server side to render that HTML.
You mean VDOM?
Yeah. Yeah.
Sort of, not really. There's a special renderer that runs, but that's a very complicated topic to, to get into.
I knew the stuff, so maybe it was. I just wanted to get. Did you take a benchmark between the response time? So the number of requests per second on a next versus quick comparison.
Right. It's on a server. I don't remember the number, so I'm not going to say anything. I'm pretty sure that we are either the same speed or slightly faster, but it should be in the vicinity.
More or less in the same.
Right, but most pages are SSR'd, right? Sorry, SSG'd.
Yeah.
And so moot point, right? Most people just put this stuff in the CDN cache, and so it doesn't matter how long it takes to generate. But I want to show you one thing, which is Dream Demo Quick, which was written by yours truly, Giorgio, in the back here. What do I do? I know. Hold on. Can I get English here? Okay. Sure. Don't get me started. That was the most useless thing that EU did. Like, they made my experience horrible. Like, I have to click now all the time on some buttons. Sorry. Okay, so here is a demo page. And so what I want to show you is, you see these links, these little boxes here? All of these boxes are coming out of a separate edge worker. So this is a separate edge worker as this. So they all are basically rendering portions of the page. And then these portions of the page are assembled together as a micro front end into one cohesive application. Now, the thing you can do is, imagine you have the front end, and the front end basically says, okay, I want to like do Amazon level personalization. So I can't cache the whole thing, right? But a request comes in and you're like, oh, I need the menu. But everybody's getting the same menu. I can just talk to the CDN and like cut and paste a piece of HTML string that's the menu. And this is exactly what's happening over here, right? And then you come across the shopping cart and you know, like, well, you need to know how many items you have in a shopping cart. So in that case, I have to do full rendering. But like, oh, I need to show a hero image. But there's only like 400 hero images to choose from because I'm only running X number of campaigns, right? So again, I just need to like go to the correct CDN URL and like cut and paste the HTML over there. And the same thing for product or comments or anything else. And so in this particular way, you can have high level personalization and at the same time not pay the cost of SSR rendering. Because SSR rendering is kind of expensive. The only way to really do efficient SSR rendering is to do string concatenation. And it's something that we have plans long-term with Quick, but we're not there yet. Okay. Happy to chit-chat later. I think I'm out of time and questions, right?
Yes.
Okay. I'll be around wondering. I'm a friendly guy. Oh, I do have to finish every single one of my thing with a joke. And so, you know the T-Rex, the dinosaur? Why can't T-Rexes clap? Because they're extinct. Okay, good night.
Thank you.